Okay, it's time to review for the fourth 6 weeks test. So we're going to take a look at some word problems. And again, this test is going to review concepts such as proportions, scale factor, surface area, and volume. Let's go ahead and look at the first question. Here we have Daniel and Katrina, who both walk home from school. They leave from the same place, and Daniel walks 10 blocks north to his house, and Katrina walks 24 blocks east to her house. How many blocks apart do they live from each other? So what we have here is Daniel that walks 10 miles from this point, and then Katrina walks east 24 miles. And then when we try to determine the distance they are apart from each other, from here to here, basically we've created a right triangle, and we need to solve the diagonal, also known as the hypotenuse of a right triangle. We're going to be using the Pythagorean theorem, which is a squared plus b squared equals c squared. And remember that A and B represent the legs of the triangle, so I can use 10 as one of the legs, 10 squared plus 24 squared, and those together equal c squared. Now let's go ahead and work this out. 10 squared is 100 plus 24 squared is 576, and all that together again equals c squared. Now when we add 100 and 576, we get 676, and that equals c squared. Well, 676 is obviously not our answer if this is how far apart they are, and one is watched 10 and 24. Our final step is to be sure and we take the square root of both of these. Of course, the square root of c squared is c, and then the square root of 676 is 26. So C is 26. So they are 26 blocks apart from each other. This question says that Melissa has a painting in her room with an area of 40 square inches. She has another painting that is twice as long and twice as wide as the smaller painting. What is the area of the larger painting? Okay, keywords in this question is that the new one is twice as long and it is twice as wide. If you see twice on both of those, the length and the width, that means we have a scale factor of 2. Scale factor of 2. But let's go ahead and just kind of sketch a diagram and see what this looks like. If we have a picture or a painting and it measures 40 square units, we could just make up some measurements. Let's say it was an 8 by 5. If we multiply 8 times 5, we get 40. So the area of that one would be 40. And if we drew another one which was twice as long and twice as wide, it might look something like this. Of course, this is not perfect, but let's pretend. Of course, if this measurement was 8 and it's going to be twice as long, that would become 16. And then twice as wide as 5 would be 10, and if you multiply 16 times 10, you're going to get 160. So 160 would actually be your answer. But what you also have learned is that when it comes to a scale factor, you can determine the influence on the new area by taking the scale factor of 2, and since we're talking about area, you will square the scale factor, and 2 squared is 4. So what we have here is we take the original area of 40 times 4, which is the scale factor squared, because we're talking about area, and 40 times 4 is 160. So again, 2 ways to solve this problem, but the answer is 160 for the area of the larger painting. This question states that an octagon with an area of 50 square inches is dilated, keyword, is dilated by a scale factor of 3. Again, here's scale factor, and our scale factor is 3. What is the area of the new octagon? So since we know the scale factor, we don't have to go to the trouble of drawing the octagon. We can actually simply use the original area of 50. And since we are talking about area, we're trying to determine the new area, we're going to multiply times the scale factor squared. Well, I'm sorry, I put a 3. Let's back that up. 3 squared, the scale factor squared. So when we take 3 and we square it, which is the same as saying 3 times 3, we get 9. So it's going to be the original 50 times 9, which equals 450. So the new area is going to be 450. This problem states that a local store uses boxes, as shown below, to package the items they sell. What is the surface area of the box that would need to be wrapped with wrapping paper? Or what is the surface area of the box that would need to be wrapped with wrapping paper? Okay, so we're going to wrap the entire box. So we need to find the surface area of the entire box. And when you look on your formula chart, it's going to give you a formula for surface area of a prism, and it's going to be pH plus 2b. Now, I'm going to get back to that formula, but let me show you another way we could do this. We could actually identify the different faces, such as this face right here, which is 10 by 8, which would give you an area of 80 because we multiply them. So we have a 10 times 8, which is 80. And of course, we're going to have two of those, one in the front and one in the back. We also have this face, which is a measurement of 12 times 10. There would be a 10 here. I know that from down here. And 12 times 10 is 120. So we have another face that's 120. And again, there is going to be two of those as well. And then finally, we have this face, which is going to be 12 by 8. And when we multiply 12 times 8, we get 96. And there are two of those. When you add all that up, you will get, let's see, 592. 592 for the surface area of the box. So that's one way to do it. Just break it down into its different faces, and remember that there's two of each in this specific prism. Because it is a rectangular prism, we have three different sizes of the faces. But now let's take a look at it using the actual formula. So in the formula, we have a capital PH plus 2 capital B. The capital P stands for the perimeter of the base. So we need to identify what is the base. We could use the 10 by 8 as the base, or we could use the 10 by 12. I'm going to go ahead and use the 12 by 10 as the base, the top and the bottom. And I need to start by finding the perimeter. So we're going to have two 12s, and we're going to have two. When you add up 10 plus 10 and 12 plus 12, you are going to get 44. So the capital P, or the perimeter of the base, is 44. And then we're going to multiply that times the height of 8. So 44 times 8. Then we're going to add to that 2 times the area of the base, which is going to be the area of the base, which is 12 times 10. So when we do 44 times 8, we get 352. Then we're going to add to that 2 times, and then 12 times 10 is 120. So we have 352 plus, let's see, 120 times 2 is 240. And when you add 240 to 352, you're going to get 592. This problem shows a net diagram, the net of a rectangular prism, and it wants to know what is the surface area of the net. All right, it's actually a prism that's been opened up and drawn out in all its all its 6 sizes, 6 different faces, and we're going to find the surface area. So we simply can find the area of each individual face. Now on this one specifically, we have a 10 times 5 because we have a length of 10 and a width of 5, and when you do 10 times 5 you get 50. Well, all four of these are the same. They're all 50. So if you just add up 50 4 times, or 50 times 4, you get 200. And then we still have the two little ones. These are 5 by 5s, and when you do 5 times 5 you get 25. This one is also 25. Those two together are 50. So you add that up and you get 250, which would be the total surface area of this net drawing. This problem here states that Karen took a picture of a statue that has a 12-foot shadow. She noticed in the picture that the statue was 10 centimeters and the shadow was 3 centimeters. So how tall was the actual statue? I'm going to begin by just kind of sketching a diagram. Let's say this represents the statue, and then of course the statue had a shadow, and let's just kind of, I don't know, let's just say this represents the shadow. The shadow, we were given the measurement of the shadow, which was 12 foot. Now she took a picture of this. I'll just sketch this and say this represents a picture, and inside the picture we also of course have the statue, and the statue also had the shadow, and in the picture the shadow was 3 centimeters and the actual statue in the picture was 10 centimeters. 10 centimeters for the statue. So we have a ratio in the picture of the statue to the shadow, and it's 10 to 3. So I'm going to use that information. Again, it's 10 to 3, 10 being the height and 3 being the shadow. So I'm going to set that proportion equal to the ratio, or write the same ratio for the actual statue. Now I don't know the actual statue, but I know its shadow is 12. I have now created a proportion. 10 to 3 is equal to x over 12. We can cross multiply and divide. 10 times 12 is 120, and then of course you divide by 3, and 3 goes into 12 4 times, and you're left with a remainder of 0. So you put a 0, the answer is 40. You might also notice that 3 times 4 is 12, so 10 times 4 is 40. Now some of you may be asking, we have one unit of measurement in feet and the other in centimeters. It doesn't really matter. We use the same ratio of 10 centimeters to 3 centimeters, which was a 10 to 3 ratio, and we applied it to the 40 to 12 is in the actual statue and its shadow, and it is in feet, but it's still the same ratio. So the answer is correct, and the answer is 40. Okay, in this problem we have two similar rectangles, and it says that it has a scale factor of 3 to 5. So 3 to 5 is the scale factor from smaller to the larger. Then it gives us the perimeter of the larger rectangle, and it says that the perimeter is 65. So we're trying to figure out what is the perimeter of the smaller one, and we're going to use this ratio of 3 to 5 in order to determine that information. So we need to start by writing our ratio of 3 to 5. We'll write it as a fraction, 3 to 5. Of course, 3 represents the smaller one. The smaller one is what we're looking for as far as the perimeter, and we compare that to the perimeter that we know, which is 65. So we have our proportion set up, and we need to solve the proportion. The way that you solve a proportion is to cross multiply and divide. 65 times 3 is 195. And then we're going to divide by 5 times x, which is 5x. We need to divide by the 5 to determine what the x is. 5 goes into 19 3 times, which is 15. We have a remainder of 4. Bring down your 5, and 5 goes into 45 exactly 9 times. So our answer is 39. Perimeter of the smaller rectangle is 39 based on the ratio of 3 to 5. Okay, in this problem we have two cylinders and they are said to be similar. Anytime you see the word similar, you're going to be setting up a proportion to solve a missing or an unknown measurement. And it says specifically to find the radius of the smaller cylinder. So let's look at the information we are given. You can see that we have the diameter of the larger one and that it is 9. And then we have the length or the height, which is 5. So we have a ratio there of diameter to height, and it's 9 to 5. However, we're looking for the radius. So let's go ahead and determine what the radius of the larger one is. If we know that the diameter is 9, then we can simply divide that by 2, cut it in half, and we would get 4.5 for the radius. So now we have a radius to height ratio that we're going to use to determine the radius of the smaller cylinder. So let's write that as a fraction, 4.5 over, let me back that up, rewrite that real quick. We have a 4.5 radius to a height, cylinder height of 5, and we're going to set an equal proportion. Again, we do not know the radius, but we do know the height of 3. And we have set up a proportion, so we're going to solve, and again, the way you solve is to cross multiply and divide. 4.5 times 3, this 4.5 times 3 is going to be, let's see, what is that? 13.5. And then we need to divide that by the 5. Let's see, 5 goes into 13 2 times. We have a remainder of 3. Bring down your 5. Don't forget your decimal up here. And then 5 goes into 35 7 times exactly. So our answer is 2.7 will be the measurement of the radius.
Made with Doodlecast Pro.